taking out those common factors to simplify, and then the addition process, they've got the same denominator, then you can just write the denominator one time and put the appropriate terms in the numerator. On this one and this end, it's just 8x plus 40. This one was 11x minus 5x. All right, so go on to number 4. So this one is subtraction. Okay, that's subtraction. There was only one term being subtracted, so we just subtract the 1. Anything else I can do? At this point, if you have any like terms, you combine them. Good. So that's x squared, 5 plus, minus. So that's x squared minus 4x over x minus 4. Right, and then up in the top, we can factor by taking out the GCF of x. X minus 4. So those are now gone, and yeah, you're right. So we just left with an x. Go on to the next one. The next two are subtraction. All right, now we got to watch this. This is something we looked at the end of the last class about. That one's going to factor backwards, so remember how we handle it. On Thursday, there were ones that we got in the middle of the page on the last section, and there was a couple of tough ones. Well, those really should have been at the end because of the fact that they just were kind of misplaced in their complexity level. So now, this factors as 3 minus x and 3 plus x. And so that's 3 plus x. Now, this is x plus 3, but with addition, it really doesn't matter. I'll show you what I mean. We can easily turn that one around. To show that it's the same. You could have easily taken it out there with no problem, but Now, what's left over is 3 minus x, okay? Another way of looking at this is, and like I said, this is going to rear its ugly head once in a while, that's negative x minus 3. Because let's see, Ross, you got an x minus 3 there. But if you had a negative in front of the parentheses, you'd be right, because negative x would give us negative x. Negative of negative 3 is plus 3. So this is technically the answer there. But I was showing you in this how you can make it into an x minus 3. So in the event there had been an x minus 3 down here, you could take these two out, but you got to put a negative sign in front of the 3 plus x, or the x plus 3. All right, just remember that. I'll kind of show you what I mean over here. I think I told you over here, but I can't remember because, like I said, I got several classes. But anyway, x minus 3 over 3 minus x is equal to negative 1, okay? That's important because these two are not the same. If there's an addition sign in between them, it doesn't make a bit of difference because addition is associative. You can take the two parts and swap them around with no issue. But with subtraction, it's not associative. X minus 3 and 3 minus x are something entirely different. And really what it amounts to is it's a negative sign. That's one thing that makes it different. All right, so last one on this set. I'll give you a couple minutes because on that one, you're going to have a little factoring. No, you might not have any factoring to do on that. I forgot. Yeah, you're going to because it's going to create. But anyway, you'll see. Give it a try. You're going to have a numerator that's a trinomial, so you'll have to factor. All right, so same denominator, so we're just going to write it once. And then up here we got the x squared minus the x minus 1. And then we got minus, like I said, you're subtracting the whole thing. If you need to put this in, you put it in, because generally what ends up happening is the people will negate the 5x, but not the second value, especially if it's negative. They'll think that that's already done, and it's not. You've got to apply that negative sign to everything there. This is going to be hard squeezing this one in. So minus 5x, I'm going to put those two together. And then negative 1, and then negative 26. All right, so that's everything involved in the second part with its sign change, the negative 5x and the negative 26. So negative x and negative 5x is negative 6x. And then negative 1, negative 26 is negative 27. Now, as I've tried to tell you in the last section, when you're simplifying these, use anything that's already factored or use the easiest factoring one once you've got it factored to help you factor up anything that's factorable rather than going through the whole process. So negative 9 goes into negative 23. Well, 3 times. So that's x plus 3 is the other factor. And then x minus 9. So what does that factor out to? Well, the x minus 9 and the x minus 9 are gone. All we got left is the x plus 3. Does that look good? Did I make any mistakes? All right. All right, so that's all of the like denominators. All right, so what happens if we don't have a like denominator? Well, let me kind of refresh your memory. Let's say we've got 7 thirds, and we're adding 2 sixths. All right, we cannot add those as they are because there's no like denominator. All right, so let me see something. I'm kind of surprised I didn't start out with one where you just got to multiply one side. But anyway, you got to find the LCD, and in this case, the LCD is 6. So in this case, the second term's already got it, but we got to find the factor that turns that 3 into a 6, which is 2. And when we multiply the numerator by 2, we got to multiply the denominator by 2. So then when we put these together, we got 14 plus 2 over 6. Once we determine the common denominator and adjust for it, then we can do the same thing we did up here. So this is equal to 16 over 6. Anything we can do to simplify, and it looks like the common factor is 2 again. So this is 8 thirds. All right, so to show you this process here that you're using, let me just kind of come up with one. Let's say we got 7 halves, and then we're going to add to it 2 thirds. Again, we cannot put these together as they are because they don't have a common denominator. You know, if you don't have a common denominator, you can't just pick one and because it looks good and we'll use this as a denominator. You've got to find the LCD. Now, in this case, the LCD is really easy to find because it's just 2 times 3, which is 6. So that means this side has got to be multiplied by the missing factor, which is 3 over 3. And this side is going to be multiplied by the common denominator. I'm sorry, the missing factor, which is 2. And when you find that number, you've got to multiply numerator and denominator, because this right here is functionally equivalent to 1. This one here is functionally equivalent to 1. All right, so what does that give us? That gives us 21. And then this is 2 times 2 is 4, all over 6. So this is 25 over 6. In this case, there's nothing to simplify. All right. So this is kind of the basic case here, when you just have one term to adjust because the other term already has the common denominator. This is when neither one has the common denominator. So you got to multiply both by the missing factor to give you the common denominator. All right, so let's look at this example. They got 3 over x plus 3 plus 2 over x. Now, it might be tempted to think, well, I could just multiply by 3, but that's not a factor here. That's x plus 3. We don't know what x is, so 3 is not going to work. We've got to multiply by the LCD, and the LCD is just multiplying these two together like we did down here. The LCD is x times x plus 3. Because remember, x is a variable, so we don't know what it is. So we use x times x plus 3 as the LCD, multiplying these two. Now, how do we handle this? Well, we handle it just like we did over here. We got to multiply the missing factor. In this case, it's exactly like this one here, in that we're just going to multiply by that other side here. In a sense, you could essentially just multiply kind of going across like this, and that'll do it. That's formally not, it's not a formal process in math, but that's what it happens. 2 times x plus 3. Do that. And then 3 times x over the LCD of x plus x times x plus 3. And then after you've got that LCD, you're just going to put both terms, numerators, over that LCD and simplify. So 3x plus 2x, and 2 times 3 is 6. 3x and 2x is 5x plus 6. There's not anything that simplifies. There's no common factor in the numerator. All right, so we got 4 of these. Well, they only got 2 of those down there because they take a while. But like I said, we shouldn't be taking. We shouldn't be taking and get ready for break. Okay. So try number 7. First of all, what is the LCD? You got a 5 here and a 4 there. They're not the same, so you got to find an LCD. For most all of these, this one is a little bit weird. This is that -1 thing I was telling you about. You can simply multiply these two together to find that LCD. Exactly. It's 5 times 4 is equal to 20. So now, really, all we're going to do is we're going to take 6 over 5, and we're going to multiply that by the missing factor that gets us to 20, which in this case is 4 over 4. That's multiplication. 4 over 4. Minus, and then the missing factor here is 5. Oops, it's 7x. right, so 4 times 5 is 20. So let's put everything over that common factor. 4 times 6 is 24. Minus, and it's 5 times 7x is 35x. All right, now, anything we can do here to simplify? I don't believe there is, because there's no common factor between 24 and 35. All right, so y'all try the next one. I'm going to give you all a bit of a hard. Well, first of all, let me just ask you the LCD, and then I'll give you some time to work on it. What's the LCD? Remember, it's the same process as we did over here. Since these have X's in them, we don't, they're not going to be numbers. It's going to be a number at one point whenever we figure out what X is, but we're not doing that here. We took these two and multiplied them. So what were they? 3x. All right, so that's the LCD. So we just multiply each side by the missing part. Let me know when you get an answer on it. All right, on the left-hand side, what's missing? It's missing the x plus 3, 2x plus 3. So both sides have to get multiplied by 2x plus 3. Well, this one's already got 2x plus 3. I mean, the numerator and the denominator have to be multiplied by 2 plus 3. All right, so this is multiplied times 5. And then this is multiplied by the 3x. I'm not going to multiply the numerator, the denominator, because we're going to leave it factored. The numerator, we have to simplify that once we find out what we need. So it's missing the 3x. So multiply numerator and denominator by 3x. So what do we get? 5 times 2x is 10x. 3 times 5 is 15. And then here it's plus. 4 times 3x is 12x. All over the 2x plus 3 times 3x. All right. So we combine anything we can, which in this case is just the x's. And it doesn't look like, oh no, this is divisible by 3. Both of these are divisible by 3. And that's important to realize. This is a multiplier. This is a factor. All right, so it's legal to do this. And we only need the 3 because 3 goes into 24 8 times, and it goes into 15 5 times. So that means we've got and that's just an x now. I'll put it in the front. All right. You cannot factor the numerator any further. So I do believe that's finished.
Where did you get the 24x?
Well, let's see. Did I make a mistake somewhere? Oh, it's 22. I'm sorry. Well, that's a good thing to ask. 10x plus 12x is 22x. Sorry. So then that means there's nothing else to do on this one. So thanks for pointing that out. Now I know y'all are awake, because it doesn't look like I am. So it looks like that's the end of the road for it. I thought that was kind of strange that it went that a little bit further and yet didn't simplify any. So all right. 22x plus 15. So that's all we can do. This is all still in there because there's no common factor on each of those things. So this is where to the road. Yeah, it's right there. All right. So there we go. All right, so on this one, what's the LCD? Don't let it intimidate you that they got X's in it, because all you're doing is just multiplying them. And if they are numbers, you can take it out to hit to this. What's the LCD on this? Number 9. There's half of it. There's the other half. So the LCD is what? Just multiplying them. So what's that LCD? All right, that's the LCD. So essentially, you're just going to multiply. And this is one way you can do it. And I've showed people how to do this to get through basic math like this, algebra. You can simply just multiply across like that, multiply across up there. And then you're essentially doing the same thing that you're doing there. Because this makes it looks a little bit way too complicated. So the LCD is that the 5 gets multiplied times the x minus 3. We got that negative sign. And then the 4 multiplies the x minus 4. It's a negative 4. That's important because you got to multiply both of them. So 5 times x minus 3 is 5x. And 5 times negative 3 minus 4 times x is minus 4x. Minus 4 times minus 4 is plus 16. And this is all over our LCD. Which means what? How can we simplify this?
Start by combining the like terms.
Yeah, so these two go together, and these two go together. So that's 5x, take away 4x, so that's just a plain old x. Negative 15 plus 16 is just a plus 1. And I'm kind of expecting that some of these will simplify down, but they haven't yet. So if there was an x plus 1 down here, we could take out the common factor, but there's not, so we just leave it unsimplified. All right, so that's it. All right, now here's the thing is, this is what I had showed you over here on this board. Remember, if they're backwards, then it's a factor of -1. So 2x, see 3x minus 2 See, these are not exactly the same because of that negative sign. If both of them were positive in the middle, they'd be exactly the same. But since the negative sign is the negative sign, what that does when they turn around, all right? 2 minus 3x. So see, what that means is that a factor of -1, essentially, you can put that there, just like you do when you're doing that factor by grouping. If you don't have any factor, you can take out a 1 or a -1. So what's missing on this is just to multiply this by a -1. All right? So all I'm going to do is I'm going to multiply this one times the -1. And you know what it's going to do? It's just going to change that to a positive, but it'll turn this one around. You can essentially do this. And then you could multiply just like we've been doing, but I'm pretty sure we're going to be able to do this by, let me just check before I can get into that. I feel like I'm rushing a bit because but take a break, but let me see if I can get a pen and do this. What happened to my pen? All right, hold on. All right. So what stops these from being the same? Let's see. It's just a factor of -1. I want to just check it real quick so I can make sure what I'm telling you is right. All right, so yeah, I'm right. Just want to make sure. All right. All right, so this is the factor, but remember what I told you over here. If you recognize this, you recognize it, that these two things are not the same thing. But if you introduce this factor of -1, then what that's going to do is make them the same. So this can be a short one by doing such. All right, so using the factor of -1, in order to turn this around, I'm going to just put the negative sign in front of 3x minus 2. In other words, now these two exactly the same. The only thing that's different is that negative sign. But we've got a negative and a negative, so what, you know what that does? That makes this real simple. It makes it into 4x plus 7 plus. So a negative, then that gives you the positive. Now, like I said, you can go ahead and do this by multiplying this side by the 2 minus 3x, like that, and then multiplying this by the 3x minus 2, and you'll have a lot more terms, but this simplifies it down, and now all you got is an addition, which is 4x plus 7 plus x minus 2 all over 3x minus 2. Collect the like terms, which is 4x, and then these two are the same, which is the whole numbers. And so you got x, 4x plus x is 5x. 7 minus 2 is 5. All over negative sign there. Anyway, now the only thing you can do is just factor out 5, but that doesn't help us any, so we're just going to leave it like this. All right. All right, so take a gander at that, see if you got any other questions. And then when we come back, we might as well go ahead and take a break. We'll look at those last couple of problems. There's really only a couple, because these are the most complex ones, because you have to factor these and then determine what the LCD is. So they only got a couple of those because these are the tough ones, but you have to factor them. These, for the most part, were already factored. So if you have questions, I'll be here for a few minutes, and then I'll see you a little bit later, and we'll finish up. We don't have that much to do, and then you can use the rest of the time to work on completing your homework. And please take advantage of having that day off to try to make sure you're current with your work, because we got another test coming in next week at this time, all right? And since this is the toughest stuff, you know, it's going to be hard to learn that just in a couple of days. Use the whole 5 days that we got off. So any questions? Okay, so example 3 is kind of the toughest one, but this whole lesson is tough because it's just not natural that people to like fractions. It's something you got to work at, and it just gives you a headache to deal with them. And this one is the one that tests that. Now, in order to find the LCD, it's much easier to do this by fractions. You can follow that same procedure in multiplying the x plus 1, like by this down there, and this by the x squared minus 9, but you're still going to probably have to factor at some point. So if you want to give that a try, try it. But I'm going to use the factoring as a way to find out what the LCD is, determine it, and then multiply by the missing factor. All right, so the 4x minus 12 is very simple to factor because there's a common 4. 4 times x is 4x. 4 times negative 3 is negative 12. So that's factored. So there's the factors on the right-hand side. This one, the x squared minus 9, that's that difference of squares that factors as x minus 3 times x plus 3. So now you have all of these things here. I'm going to kind of just write them here. Because they tell you what the LCD is, but I want to show you kind of a little bit alternate way how you determine that. All right. So the x minus 3 appears in both one time. So that's definitely part of the LCD. It's here and it's here. It only appears once. So you keep it in, put it in there once. Same thing with the 4. There's a 4 on one side. So that's going to go in there. It's just got to appear on one side. Now this one over here has both the x minus 3 and the x plus 3. We've already got the x minus 3 accounted for, so we just throw in the x plus 3. So there's your LCD. All right. So our goal is to multiply the numerator on each one by the missing factor. We know we got to have all of these things down there. This one right here on the left-hand side was missing the 4. It had x minus 3 and x plus 3, so the only thing that was missing was the 4. Now, we already know what, and like I said, this is very formal, and as a shortcut, I would just tell you that really the only thing that needs to be multiplied by 4 is just the x plus 1. Once you've determined the LCD, you can just put it down there one time like that. So 4 times x plus 1 is 4x plus 4. This one, the missing factor was x minus 3 because there was no, I'm sorry, the x plus 3, because there was no x plus 3 on the right-hand side. So we got to multiply the 5 times the x plus 3. So that's a negative 5, essentially, because it's a subtraction. Negative 5 times 5 times x is negative 5x. And negative 5 times 3 is negative 15. All over that LCD. Like I said, the real work is in the numerator, because once we determine what the LCD is, we know what it's going to be. We just got to multiply that numerator by the missing term, or the missing factor, I'm sorry. In this case over here, it was 4. On this case, it was the x plus 3. So that's why they show that part right there, because that's important. And you got a negative sign there, so that affects both those terms. So then we collect like terms. 4x minus 5x is negative x. 4 minus 15 is negative 11. All over 4 times x minus 3 times x plus 3. If it's possible to simplify, you could. In other words, if there were an x minus 3 or an x plus 3 in the numerator, you could take that common factor out. Or if there was a common factor of 4 up at the numerator, you would take it out. So I'm going to just try to lead you through these because it's going to be tough probably to do it all at once. But anyway, we're going to factor them first. The denominators, that is. You don't need to do anything with the numerators on these yet. All right. So the only thing you can take out is a 2, and it's an x plus 5. All right. Plus. In here, this is that same thing that keeps coming. It's the difference of squares. X minus 3. I'm sorry, x minus 5. X plus 5. All right. So what is the LCD? You got to make sure you have all the factors. The one I would start with is the one that's in both, which is the x plus 5. It just has to appear in one of them, but if it's in both, then we know we got to use it. X minus 5 appears, so at least appears in once, we got to use it. And then there's a 2 on one side, so that comes out over here. So this is a kind of a little sloppy. The 3 should be right into the middle and the 5, but it's not that big a deal. So answer me this. Which one of the LCD factors is missing on this side? You got the 2. You got the x plus 5. So which one's missing? Hint. This one is missing the x minus 5. So we got to multiply by the x minus 5. And the more important thing to do is multiply the numerator times what's already up there, because we already know that the LCD is 2 times x plus 5, x minus 5. Once you find out that LCD, that's what's going to be down there, one time for all. Plus 3 times, and what's missing on this side? Which one of these 3 factors is missing? What's missing? The 2 is missing. See this one? It had x minus 5 and x plus 5, so the 2 was what's missing. So this 5 times x is 5x. And then 5 times negative 5 is negative 25. And then it's 3 times 2, which is 6. And I'm going to just leave those factored down there and simplify. And the only thing that needs to be simplified is these 2 terms. All right, so that's 5x minus 19. And it looks like none of these are going to simplify any further. You get a strange number like 19 which is prime. You know, you can't take anything out. Oh, this is 5. So there we go. All right, so on this one, what's the factors on that left-hand side? Well, I guess I'm going to have to put it over here. It's not going to fit. Because the only way you can tell what the factors are is to factor it. This is not like when you're dealing with just plain old numbers. So this is x minus and x plus something. So what two numbers multiply out to be 15 and have a difference of positive 2? All right, so those are two factors right there, right? These are the numbers. There's only two factors of 3. There's 1 and 3, and we need to have the 3 be larger. So this is x minus 3. So the LCD is what? What's that LCD? Just go through and take all the factors out. We got the factors written, so what is an LCD? X minus 3, good. Glad to see you still with us, Ramey. All right, so that one's taken care of. And then you also use it if it just appears once. All it's got to do is appear once in either side to be part of the LCD. So that's x plus 5 appears once. And then we need x plus 1. So there's your LCD. So what you got to do is you got to multiply. And like I said, I'm going to kind of skip all this because I think in a way this is kind of confusing. Because once we've determined what the LCD is, you know, that doing on the bottom is not really so much needed. It's just the formal process of showing you that you have to multiply top and bottom by the missing factor. But once you determine the LCD and put it down there, you've effectively done that. So all you got to do is just multiply the numerator. That's the important part. So up here, the missing one is what? Which one of these is not up there? Or not down here, I'm sorry. Which one of those up there is missing? Hint, what is it? X plus 1. And then this side is missing the all right. So up here we got 4x. 4 times positive 1 is 4. Since we're subtracting, we got to remember this negative 7 affects both. Negative 7 times x is negative 7x. Negative 7 times plus is negative 35. Combine the like terms, 4x minus 7x. It looks like they're just giving us spaghetti up top side, because I was thinking it would be some in here where we could, factor out. I don't think that's going to happen. It may, well, it won't. We'll see. 4x minus 7x is minus 3x. 4 positive and negative 35 is negative 31. And no, there's no common factor up there. No way you can factor that numerator. So that's it. All over these common denominator. Now, if it was possible to take out something and it ended up being one of those down there, then you would simply strike it out. But there's not, so we're done. And you can take a negative 1 out, but that doesn't do any good because it's there's nothing to give you either one of these, so you just leave it. All right, any